Section 2 is on graphing functions. Now, as far as graphing functions go, there's a couple different ways you can graph a function that we're going to talk about. But one of the ways that they describe is to insert random points. So if I give you a function, I'll just give you x squared like that. Then what I usually do is I set up a table. Now again, like the last section we talked about, f of x is the same as y equals. So in this case, we're basically finding ordered pairs again. So if I put 0 in for x, then I get 0 squared, which is 0. And again, that is my ordered pair 0, 0, and that would go on my graph. So as I make my axes, 0, 0 would be right there in the middle, and then I go to another one. If I put 1 in there, 1 squared is 1. So over 1, up 1, make that. Then when I go to the next one, I also like to do negatives, just so that way I have a little bit of both positives and negatives, not just all positives. The numbers that you pick doesn't really matter, but I typically stick with -1, 1, 0, -2, and +2. It's just so at least those 5 numbers, so that way you get a sense of what's actually happening. In this case, could you do more? Absolutely. You can do as many ordered pairs as you think you need in order to make the graph. Me personally, I think it's kind of one of those things where we can do this, but how many points are you going to need to make a certain graph? Okay. Quite a few. Some of them you could do many points. Hopefully by the end of the chapter you'll kind of figure out what kind of graph this was just by looking at it, rather than inserting a bunch of random ordered pairs. On the last one, if I put -2 in there, I also get out 4. So this is actually a parabola, and it comes in here like so, and comes out, and I'm done. So as far as me sketching a graph by plotting points, how many points do you need? I would say at least 5. In some cases I would do more. For example, if you were given a graph, and let's say the graph looked like this, where it went, how many points would you need to make that look like that? I think you would need quite a few. And as far as how to get them to inserting ordered pairs, if you inserted 0, 1, and 2, for instance, 0, -1, -2, you might not see exactly what you're supposed to see. For instance, you wouldn't see this, and you might not even see this part over here. So the plotting points method is okay if you know what type of graph it is, like if it's a line, maybe a parabola, a circle. But for most of these, the plotting points method is going to be too much to handle. So it just depends on what kind of graph it is. The second way is if you have a graphing calculator. Now, for this particular piece right there, f of x, we can replace that with a y equals. And now I put it in my graphing calculator. So I hit the y equals button, and then you would hit the x button, and then you would hit the x squared button. And then for me personally, I usually go zoom 6 just to get that standard window, just to see what kind of graph it was. If it needs to be changed, then we change that. If it doesn't need to be changed, then we're good. Again, how to change a window is you'd hit the window button, and underneath there, x minimum stands for if you need to move left. X maximum means if I need to move to the right. Y minimum needs down, and Y maximum means up. The X scale and the Y scale doesn't really do anything other than change the amount of tick marks that are on your axes, but those are the main ones that move it up and down, left and right. So if you don't see a bottom, for instance, or if you don't see the top, for instance, then you might want to change that window up. If you change the window up, then I would suggest you write down what you changed it to, just so that way the person that's grading your stuff has an idea, because your window could be different from his, which could be different from hers, and all of a sudden you've got 20 different windows graphing the same graph. And which one's right? They all could be. So just be careful with that, as far as if you ever do change the window, then make sure you tell the person, whoever is grading it, what you changed it to, just so that they know what you're looking at and see if it's right from there. So as far as graphing it on a graphing calculator, you would put that into y equals, especially on a Texas Instruments TI 83 or 84, and hit x squared and hit graph and draw what you see. Okay, so that's kind of the gist of it. I would suggest using a graphing calculator as much as you can, just because they are more accurate than your hand homemade graphs and whatnot. Then how would you transfer that to a piece of paper? Is that you would copy what you see, okay, and that's how you would graph it. As long as you have things labeled, it's going to be the same as what you had. So that's how to graph with a graphing calculator. The next time, or the next type, is what they call a piecewise defined function. Now, we talked about piecewise in the first section, as far as how and what a piecewise is, and basically it's two or more pieces that make up a picture. So the one I've got here has x squared and then 2x plus 1. Now, just to kind of explain a little bit about x squared again, x squared, this part right here is a parabola piece. This part here is a line piece. Now, how did I know the difference? Well, with the x squared, that tells me that it's a parabola, and since that's the highest exponent, then that is the determining factor as far as what kind of graph it is. The 2x plus 1 is a line, because the highest exponent of the x is a 1, so that's a linear situation. So what's going to happen here is we're going to have two different pieces. We're going to have a parabola piece and a line piece coming together to make one graph. Okay, so the first thing that I do is I start to draw it. Now, x squared we've dealt with a couple different times now. We did it on the graphing calculator, and we also did it by hand. So I kind of know what the shape of the picture is going to be. I'm going to put it in orange just so that we have an idea. And that's the parabola coming in here, like so. Okay. And then we have the line. Now, the line, when it's in this type of format, that's like saying y equals 2x plus 1. And when you graph a line in that format, 1 means the y-intercept, so I go up to 1. And 2 in front of the x is my slope, so that means up 2 over 1. And I have this line coming in here like so. Now, that's not the whole point of this thing, isn't to make a line and a parabola intersect like that. It's actually, there's restrictions. Okay, these things right here, I'm going to circle them in blue. These two pieces mean I turn it off and turn it on. Kind of like when you leave the room and you shut off, turn on a light switch and turn it off. That's basically what we're doing, is we're going to shut off the light and turn on the light on one side. So what I do is wherever this number was right here, I make a kind of a dashed line down the middle of it, or down it, just so that I kind of know where I'm working with. Now, in the first one, the first line, it says if it's less than 1. So less than 1 means left, which means the only part that should be turned on is the parabola. The line should be gone. So now I'm going to take my eraser and I'm going to erase the green line out of there. Then, on the other side of that, when it says greater than 1, the only thing that should be turned on is this one, or the line part. So then the parabola should be gone on this side. Okay. Now, as far as the different pieces go, the parabola said included. So when you have included, that means a closed circle. And the line said not included, so that would mean an open circle there. And we've made our piecewise defined function. We turn the parabola on to the left, and we shut it off to the right. On the line, we shut it off on the left and on the right. So that's how a piecewise function goes. If you have more than one piece, then I'd have another piece over there, and we'd draw it and turn it off and turn it on. So as far as those go, that's that's it. That's what a piecewise function looks like. It's multiple pieces coming together to make one picture. And the last thing that we have involved in this section is a graph in fact a function? So one of the things that we use to do that is we use what we call a vertical line test. What this does is tells us if a graph is a function. Okay? So in order to do that, what happens is, in order for it to work, if any vertical line only hits the graph once, then it is a function. Okay, so I'm going to draw a bunch of graphs here, and we're going to determine whether or not it's a function based off of the graph. Okay, so as far as that goes, if any vertical line only hits it once, then it's a function. So if I hit it more than once, it's not a function. That's how that's going to work out there. So if I draw the parabola, for instance, the ones that we've been working with, now draw any vertical line. I'll make that in blue. No matter where I draw that vertical line, I'm only hitting it once, so yes, it is a function. If I had the x to the third curve, no matter where I draw it, it's only hitting it once, so yes, it would be a function. If I had a circle, I hit it more than once, no, it's not a function. Okay, or if I had this kind of crazy curve where it's all over the place, like some roads are up in the mountains, hits it more than once, not a function. Okay. Now, if they just tell you the equation and ask you to determine if it's a function or not, my suggestion is graph it and see if it passes the vertical line test. If it doesn't pass the vertical line test, it's not a function. If it does, it is. Then on page 202 is a very nice chart that gives you all the parents, or all the ones that they start with, and then from there it changes. They give you all the ones that they kind of basically look like, and then from there they can adjust. That chart is also in the inside cover of your book. So if you forget that it's on page 202, because we're going to use that on future sections, then you can always turn to the front cover of your book for those. They talk about the linear ones, the power functions, the square root functions, reciprocal, and absolute value. Okay, so just so that you guys know what they are. Alright, so that's it for section 2. See you later.